Welcome! This is a lecture for Kron reduction method. First, let me introduce to you the formula of Kron reduction. The formula is yjk is equal to yjk old minus quantity yjn times ynk over ynn. In this equation, we have w, which stands for new, o stands for old, n stands for the number of bosses, j stands for the row number, while k is the column number. Let's proceed to the next page. For you to further understand this topic, we have provided a 4x4 matrix. This matrix has components of y11, which is negative j1.3, y12, j0.8, y13, j0.5, y14, which is equal to 0. Next is y21, which is j0.8, y22, which is negative j1.8, y23, which is j0.5, and same, which is y24, j0.5. y31 is j0.5 also, so as y32, y33 is negative j1.4, y34 is negative, y34 is 0.4, j, y41 is 0, y42 is j0.5, y43 is j0.4, and lastly, y44 is negative j0.9. First, let us define these variables. For j, we have values of 1, 2, 3. For k, we also have values of 1, 2, 3. And n has only one value, which is 4. Let us assume the values. For j is 1 and k is 1. Let's use the formula which is available in the screen. So y11 old minus y14 times y41 over y44 is equivalent to this equation, negative j1.3 minus 0 times 0 over negative 0.9, which has the final answer of negative j1.3. Next, let's proceed to j is equal to 2 and k is equal to 2. Using the equation aforementioned earlier, we will substitute the values which will be equivalent to y22 is equal to y22 minus y24 minus y42 over y44, equivalent to the next equation, negative j1.8 minus 0.5j times 0.5j over negative 0.9j, which is equal to negative j1.522. Next page, we will let j is equal to 3 and k is equal to 3. Using the formula, we will now substitute its value. y33 is equal to y33 old minus y34 times y43 over y44, which is now equivalent to negative j1.4 minus j0.4 times j0.4 over negative j0.9. The final answer for this equation will be equivalent to negative j1.22. Next, let us let j is equal to 1 and k is equal to 2. Using the equation and the formula aforementioned earlier, we will also substitute its value. y12 is equal now to y12 old minus y14 times y42 over y44. Using this, we will now have the equation j0.8 minus 0, which has the final answer j0.8, which is also equivalent to y21. Why? Because this is a symmetrical matrix, so y sub 1 and 2 is equal to y sub 2 and 1. Now, let us let j is equal to 1 and k is equal to 3. By using the formula, we will now derive the formula, a specific formula, which is y13 is equal to y13 old minus y14 times y34 over y44. This is equal to j.5 minus 0 and has the final answer of j.5. Letting this equation as j is equal to 2 and k is equal to 3, we will also use the same formula. This is equivalent to y23, which is equal to y23 old minus y24 times y43 over y44. By substitution, the equation will be 0.5j minus 0.5j times 0.4j over negative 0.9j, which has the final answer of 0.722. As you can see, y23 and y32 has the same value because they are in a symmetrical matrix. So now, this is our reduced form using Kron method. At first, we have 4x4 matrix, which we have now transformed into a 3x3 matrix. The y best new now is, in terms of negative j1.3, j0.8, j0.5, j0.8, negative j1.522, j0.722, j0.5, j0.722, negative j1.22, which is our new matrix. That's all for the lesson. Thank you.